Hey everybody. All right, we're going to begin our fractions unit right now. And let me remind you of a couple of quick things. So during the video, there will be a few times I'm asking you to press pause and do some work. I would really hope that you would do this because this is what I'd be doing in class if we were together. And it's the best way for you to see what you would do, and then we'll come back together and talk about it. Whatever work that you do during the video, when you've paused it, that will be uploaded as part of your homework. And that's one way that I can make sure that people are watching the videos because I'll see that you have done the work that was required inside the video. So here's our first one. What I'm asking you to do is press pause, copy these down, and then just circle the one that is the biggest. And then tell me briefly how you know that's the biggest. What did you do, or how do you know that it's going to be the biggest one? Okay, so I'll give you a couple of seconds to get pause pressed, and then we'll move on. Okay, so hopefully you had time to get those circled and told me why. Here's the next thing that I'd like for you to do. We've done this in class before where you are doing the easiest problem first. That should be at the top of your page, and the hardest problem would be at the bottom of your page. So you notice I didn't even use numbers. I used symbols, so I don't want to give you any hint on which one I think is easiest. So just go ahead and look at those 6 problems. Do the easiest one at the top of your page, and then the next easiest, and the next easiest. And again, this will be uploaded with your homework once you have completed the homework. Okay, and I will give you a few seconds to press pause, and then we will begin the lesson. Okay, so hopefully you had a chance to do those problems the best you could. We're going to go back to the first set of problems and just talk about kind of what you were looking at, what you noticed, how you did these first few problems here on which one was the biggest. So I'm not sure which one you guys thought was the easiest one. I'm going to make a guess on which one you guys thought was easiest. And I'm guessing you think this one is the easiest, the very first one that I did there. And the reason I'm guessing you guys probably thought that one was easiest is because it has something that a lot of people like, and that is common denominators. So when we have common denominators, we tend to like that. And so I know that if the denominators are the same, all I really have to do is look at the top number, and whichever number is bigger, then that's the bigger one. So then this would be the bigger one. And then I'm not exactly sure what you said, but here's what I would say. I would say it has more pieces of the same size. And we'll talk a little bit more about that in just a little bit. Okay, more pieces of the same size. Okay. Now, looking at the next ones, now I'm not sure what you think is easiest. I'm going to go ahead and do the second one. I think the second one's probably the next easiest one, because here's how I do the second one. If I look at it, this I think is the next easiest one. So I look at this one, and I see that this 3 right here is over halfway up to 5. And the 6 is not even half of 13. So since 3 is over half of 5 and 6 is less than half of 13, then I know that this one has to be the bigger fraction. So, and I would say it's over halfway is the reason I'm thinking there. Over halfway. Or something like that. I don't care really exactly how you say it, but that's what I would do. All right. Now I'll go to the next one. Now I got these last 2 down here. And when I look at them, I can't really do the over halfway or under halfway because they're all over halfway. I do notice that these have the same number, but we like it when we have the denominator the same. We don't really know what to do if I have the numerators the same. So I don't know if that helps me that much. And I see that both of these are over halfway, so that doesn't help me. And all 4 of these are different. So I'm guessing probably you think these are equally difficult because there's not really a whole lot of clues. I would argue that they are equally difficult, and that means they're not difficult at all. They're both relatively simple. So I'm going to go ahead and do, it doesn't matter which one I do first. I'll do the bottom one first. So here's where we need to talk a little bit about what these mean. So we have, I'm going to write numerator and denominator. Denominator. Okay, so the numerator and the denominator. Now, The question I have is, what do each of these numbers tell me? What does the numerator tell me, and what does the denominator tell me about my fraction? And usually when I speak to students, they don't have any idea what the numerator's telling them, what the denominator's telling them, but it's really pretty simple. The numerator is the number of pieces that we have, okay, number of pieces. And the denominator is the size of those pieces. So the denominator tells me how big a piece I'm talking about, and the numerator tells me how many of those pieces I have. Now, what makes fractions tricky for students is that the denominator is inversely related to size. And what I mean by that is the bigger the number, bigger the denominator, let's put denom, equals smaller size piece. So that means that a denominator of 10 is a smaller size piece than a denominator of 6. So the smaller the number, the bigger the piece. The bigger the number, the smaller the size of the piece is. And we're going to take a look at that with some demonstrations here in a little bit. But in general, that's what I like to use. So if I look at this, look at number 4 here, I see that I am missing one piece from each of these for it to be a whole. If I had one more piece of these added to these 9, I would have 10 out of 10, which would be a whole. If I had one more of these, it would be 8 out of 8, which would be a whole. So they're both missing a piece. The question is, how big a piece are they missing? So since the 8 is a smaller number than the 10, that means these are big pieces. So it's missing a large piece. And these are small pieces. And so that means that this one is missing a small piece out of a whole. This is missing a little piece, and then it would be a whole. This is missing a big piece, and then it would be a whole. Since this is missing a smaller piece, that means that this is the bigger number. So the 9/10 is bigger than 7/8 because it's missing a small piece. So what I might say here then is it's missing a small piece. And this one is missing a big piece. That makes it a smaller fraction than this one is. Okay? All right, so that leads me to these two. So if we go back to what we were just talking there a second ago, and that is that these tell me how many pieces I have, and these tell me the size of those pieces. Well, I have the same number of pieces. I have 5 here and 5 here. So now it's got to figure out which of these are bigger. Are these the bigger pieces or are these the bigger pieces? And as we just said a second ago, the smaller the number, the bigger the piece. It's inversely related. So the smaller the number, the bigger the piece. Since this number is smaller than that one, that means these are big pieces and these are small pieces. So here I have 5 small pieces. Here I have 5 big pieces. Well, if you have 5 big pieces and you have 5 small pieces, the big pieces are always going to be bigger. So here you have 5 big pieces is what I would say. So those pieces are bigger and I have 5 of them. These are smaller and I have 5 of those. So then it's going to be 5 big pieces. So what you'll notice here is I did all of these problems without ever really doing any calculations. I figured out which one was bigger through understanding what the fraction is telling me. I think we all probably did this one a very similar way. Here, I have the same size pieces. So since they're both 7ths, then I just got to see which I have more. That's a pretty easy one. Maybe you looked at this one and said, well, I know this is over half and this is under half. That's super good reasoning. These bottom two down here, the blue, I don't know how many of us are comfortable with understanding the size of the pieces tells me the denominator, and the number of pieces tells me, the numerator tells me the number of pieces. So without doing any calculations, I was able to figure out, I'm guessing many of you changed these to decimals and then compared the decimals. If you did that, I bet we got the same answers because that works. There's nothing wrong with doing it that way. It definitely works, but it's a lot more work, and especially like trying to change 8ths into decimals or 13ths into decimals, that's usually not real easy for us to do, and you didn't have to do it. I'm guessing some of you might have done a little trick that you may have remembered, and that trick looks something like this. And you might go, oh, that's, yeah, cross multiplication. There's something you can do with that. I don't teach that, obviously, that there's no understanding or concept there. It's just a trick that works. I'd rather my students look at the numbers and understand what the fractions are telling them and see if they can reason it out that way. Okay, so that's the first part that I had you guys do, and then we're going to take a look at the next part. Okay, so here are the fractions that you had to do. I'm going to go ahead and clean off the top part here, just so that I have some room to work if I need to. You guys have the directions already. All right. So I'm going to do mine easiest to hardest, just like I had you guys do. I don't know which one you guys pick. I definitely know which ones I would pick first. To me, the absolute easiest one is the star. 32 plus 8 11ths. Okay, now, depending on your comfort with fractions, you may not have picked that one to do first. I'm going to guess that many of you did something like this, because we were taught in school, anytime you're adding fractions together, you have to have two fractions. If it's a whole number, you need to turn it into a fraction. And so if I'm going to do that, then what I have to do is I have to make these denominators the same, that whole idea of common denominators. So then to make those common denominators, what I have to do is I have to multiply this one by 11 over 11. So I'm going to multiply this by 11 over 11. And so then I need to multiply 32 times 11, which I can't do that in my head. So a lot of people do a little side thing over here. They go 32 times 11, and you can multiply this however you want. You can use it a traditional algorithm, or you can use one of our alternative algorithms. The more you use the alternative algorithms, the more comfortable you're going to be with them. So this is 352 over 11 plus 8 over 11. All right, sweet. So now I have 352 over 11 and 8 over 11. And since I have common denominators, then I can just add the numerators. And so 352 plus 8 gives me 360 over 11. And a lot of questions that I have from students is at this point is, can you leave it as an improper fraction, or should you change it to a mixed number? And I'm going to go ahead and say, if we start with mixed numbers, then we should end with mixed numbers. If we start with improper fractions, then you can leave it as an improper fraction. Since we have both whole numbers and fractions, we want to convert it back into the mixed number. And again, at this point, I don't really care how you do this. If you want to use one of our alternative algorithms, that's fantastic. I'm actually going to use upwards division, because this is where the upwards division comes in handy. So I have 360 over 11. And so I know that 11 will go into 36. I should write that wider. 11 will go into 36 3 times. And 3 times 11 is 33. And 33 times, 36 minus 33 gives me 3. So now I know that 11 goes into 30 2 times, and 2 times 11 is 22, and 30 minus 22 gives me 8, and then my denominator is still 11. So my answer is going to be 32 and 8 11ths. I'm relatively confident that most of us were able to come up with that as our solution. And you might be going, holy cow, if that's the easy one, what are these other ones down here? They must be super hard. And I agree. I'm guessing most of you did not put this down as the easiest one, unless you understand what we're doing. If this is the way you know how to do this problem, you didn't put it down as the easiest one, because it is not the easiest one doing it this way. This ain't how I would do it. as you probably can figure, there's got to be another way. Well, let's just look at the answer, 32 and 8/11, and look at the question, 32 plus 8/11. Well, plus and are the same thing in mathematics. So if I have 32 and 8/11, that means I have 32 plus 8/11. Literally, when you have whole numbers and you're adding fractions to them, you can just put them together. 32 and 8/11, just like that. That literally is the amount of work that I would need to see in order to do this problem. So, you can do this, right? All this work down here, it gets you the right answer. Or you can understand what the fractions are telling us, and we could do what's in there I have right here in green. If you had 32 plus 8/11 and you said 32 and 8/11 and put a box around it, I am golden. That's perfect. So I'm gonna go ahead and erase this stuff. If that's how you did it, no worries. Hopefully we'll do it a little simpler way next time, but that's certainly nothing wrong with doing it that way. It gets you the right answer for sure. Okay, so now we look at that and say, okay, we kind of get why maybe that's the easiest one, and it's even a little bit easier. It is a little bit easier than the one I think most of you probably put as your easiest. And I'm guessing this is the one you guys put down as the easiest, the 0 or the circle. That's 5/13 plus 7/13. And the reason I think most of you said that that was the easiest one is because it has common denominators, and we like common denominators. And so when we have common denominators, it's real simple. All we have to do is add the numerators. So we get 5 plus 13 is 12. And then this is the only thing that's hard for kids to remember, is they don't actually add the denominators. Remember, these are a size of a piece. This tells me how big my piece is. I have 13ths. That's the size of it. So I'm adding this size and this size, which are the same, I'm adding together. So I still have the same sizes. I just have 12 of them instead of 13. Now, the reason I say O, or the circle, is a little bit harder than the star is because here, literally, you have to be able to add 5 plus 7 to get 12. Up here, you don't have to add anything. You literally are just putting them together. There's no addition skills whatsoever up there. Here, you do need to be able to add. So that's why I say that this one is maybe slightly harder than the other one. Okay, now moving on. Let's see, what's the next one I think is probably the easiest? For me, I think the next easiest one will be this one. And again, I'm guessing many of you maybe did not do that as the next easiest one. You probably did triangle, I'm guessing. But I'm going to show you why I think this one is the easiest. And once again, what we were taught, at least I think most of us were probably taught, to do this is put a 1 underneath this 9, just like that, which you can do. It's not wrong. What you were taught is not incorrect. It's just not the easiest way to do these problems. So I never do this. I'll tell you right now, when I am adding or subtracting fractions, I never put a 1 underneath my whole numbers. There's no reason to do that. If you do that, you are creating harder problems for your kids to do. They now have to be able to handle these 11s, right? So you're making them multiply 32 times 11. Don't do that. You're making them divide 360 by 11. Don't do that. That's crazy. We don't need to do this. I don't want them to multiply 9 times 11 and then have to do that subtraction and then divide going back. It's craziness. So I'm never going to do that. I'm not even going to do it twice today. So what I do instead is this. I'm going to give you guys a little side problem here and just tell me how you would do this one, in your own heads, or, talk it out. I don't care. So if we had 34 minus 18. Okay, so 34 minus 18. I'm pretty sure what most of us would do if we were solving this is we'd go, okay, well, I can't do 4 minus 8, so I need to borrow from the 3, even though we know it's a 30 now, and turn it into a 2, even though that's really a 20, and give it a 1, even though that's a 14, and say 14 minus 8 gives me 6. And 2 minus 1 gives me 1. That's what most of us would do. And the reason we have to do this little trickery right here is because we don't have enough from here to subtract the 8. We need 14, or we need more than 8 to be able to subtract 8. So since we don't have what we needed, we borrowed from the 3 to make it what we needed. And I would argue that's what we want to do here. I don't have what I want. What I really want to do is to be able to subtract 11ths, but I don't have any 11ths. So what I'm going to do is I'm going to borrow from this 9. So if I borrow from the 9 and make that an 8, but I still want it to equal the value of 9, so I need to add something to this 8 that'll total 9. So obviously I need to add 1 to it. So if I add 1 to this, I'm going to write that 1 so that the subtraction is easy for me to do. So I'm going to write it like this: 8 and 11 11ths. This number right here is equal to 9. I have 8 and I have 1 more, so that's a total of 9. But now I can subtract 4 11ths. And the reason I did 11 over 11 is so that it's easy for me to do the subtraction. I don't want to do 6 over 6 or 9 over 9, even though I could, that would still equal 9. I want to make it easy to do the subtraction, so I do my common denominator. So whatever that number is, these two numbers are. So now I can subtract 8. I still have my 8 whole ones, that hasn't changed. But now I have 11 minus 4, which gives me 7 over 11. And that's my answer. No reason to do a 1 under that 9 and then any of that stuff. That's just crazy, making it way harder on our students than we have to. Okay? So that's why I said that was probably the third easiest one, is because I'm going to use very similarly what I did up here, meaning I'm just going to do it the way I see it, except I'm going to change it so it's easier for me to do. All right? Okay, so that's the third easiest one. So that leaves me with the triangle and the trapezoid and the whatever face that is, okay? And I would argue these two are pretty similar. I'm going to say that one's probably the next simplest one. Not that I'm saying that one's really all that simple though. So I'm going to go ahead and do, what color am I at? Blue. All right, so I'm going to do this one. And I'm going to do, actually, you know what? I might hold off on these 3 real quick and go ahead and start our lesson. Whoops, that's not right. 5/6 plus 2/15. Because there's a little bit that I want to teach you guys on how I do these that will make more sense once we've done a little bit of our actual work that we're going to do with fractions. Yeah, I think I'll hold off on doing those just for now. Okay. Actually, while I was sitting there, I changed my mind. I think I am going to actually do at least one of these. I'm not going to do that one. I decided that one's probably not the next easiest one. As I look at them here, I think that the trapezoid is probably the next easiest one. So that one is 15 7/20 plus 9 2/5. Okay. All right. So here's how I do this one. I'm going to go ahead and make a prediction of what several of you probably did when you see these. You have mixed numbers. We normally are taught, I think what we've probably been taught in the past, is to make them improper fractions. So that means, I don't know exactly what you guys remember about doing improper fractions, but something like this, where you multiply here and add here, go like that, multiply here and add here. So you go 20 times 15, which is 300, and then add 7. So this is 307 over 20, plus, and then 9 times 5 is 45, plus 2 is 47 over 5. Okay, and now you can find your common denominator and moving on. Again, probably another big surprise. That's not how I do this problem. That to me is crazy. You are setting your students up for very difficult problems to solve. So I don't ever want to ask my students to do something like that when they don't have to. Just like I never have them put a 1 underneath this 32 when they're adding or subtracting, I never have them do this when they are adding or subtracting. There is no reason to make improper fractions when you are adding 2 fractions together or subtracting 2 fractions. There's just no reason to do that. So if we're not going to do that, how are we going to do it then? So let me show you here. Let me get back to where I was. Okay, so there we go. So what I'm gonna do instead is I say, okay, I don't know much about this problem, but what I do know is that that what I have here is I have 15 plus 9. And 15 plus 9 I can do. I'm super good at my addition skills. 15 plus 9 is 24. So I have 24 holes every time. That's what I have. Now what I haven't done yet is I haven't done the 7/20ths and the 2/5. So I still have to do that 7/20ths plus 2/5. And so the way I do this one is I notice, hey, you know what? This one is 4 times as big as that one is. So if I want common denominators, I just have to multiply this one by some value of 1. As long as I multiply it by 1, I don't change the value of it. And if I can multiply this number to make it equal that one, I'm happy. So that would be a 4. And so if I multiply this by 4 over 4, that equals the number 1. So I'm not changing the value, I'm just changing how it looks. So now what I have is 24 and 7/20ths plus 4 times 2 is 8/20ths. That's not a 20, that's a 12. 8/20ths. And now I have common denominators. And since I have common denominators, I can add them, just going straight across. So I end up with 24 from here. And then 7 plus 8 is 15 over, and then my denominator is 20. And at this point, I don't care about you guys simplifying that 15 over 20. If you leave it just like that, I'm totally fine with that. So what we notice is that sometimes the denominators are easier to do than others. And if they're not super simple like that, then I usually I have a little bit different way of doing it, which I'll show you later. So that's why I'm holding off on the triangle, because I can't see a number that I could multiply 6 by that would get me to 15. Nor am I going to do the frowny face guy, because I don't know exactly how to get from 6 to 8 or 8 to 6. But I can tell you that I know that I'm going to have 25 minus 20. So I'm going to do this one very similar to this one. It's just finding that denominator is a little bit trickier than that one was, because it could just multiply. Okay, so now that's where we're going to stop, and I'll hold off on the triangle and the frowny face for just a little bit. Okay, so the next thing we're going to talk about here is what fractions are and how they can be represented different ways. And this will take us probably through the end of the video. I don't know exactly how far we'll get into it, but the video is already getting quite long. Please remember that with these videos, you can stop and pause and then come back anytime you want. You don't have to sit and watch it during one sitting. There's one nice thing about the flipped lesson type of activity is you don't have to sit there the whole time while I'm talking. You can pause it and then come back later. But okay, so here we go. We have fractions here, and we already talked a little bit about what they mean. So the numerator tells me the number of pieces that I have. Number of pieces that I have. Okay, so that's the number of pieces that I have. And then the denominator tells me the size of the pieces. And that's true for all fractions. What makes it weird and what makes it hard is the denominator's inversely related. We talked about that before. So that means that, and I think we'll see that with these the manipulators that we have, but that's true for all fractions. And so if we have something like this, okay, so here I have 2 pieces that equal a whole circle, right? So this is the number of pieces that I have is 2. And the size of these pieces is 2. It's a whole circle because I have both of them. If I only had one of them, then this would be 1 out of 2 pieces that would make the whole circle. So the size of the pieces is how big the piece is to make the whole circle. And then the numerator is how many I have. Well, if I look at this one, so this one here, it took 3 pieces to create the same size circle as I have that only took 2 pieces. So since these took 3 pieces to make that circle, then these have to be smaller size pieces than the orange one is. And obviously it is. We already knew that it was. But that's why here my denominator would be 3, because it takes 3 of these to make a full circle, where here it only takes 2 to make a full circle. So the more pieces you need to make a full circle, that means the smaller those pieces have to be. And I can keep going. If we look at this next one here, okay, so there's my 3 pieces. I'll kind of keep them separated so you can see how many pieces there are. Now I've got this one. This one's way smaller. Okay, so for this one, it takes 8 pieces in order to make one whole circle that's the same size as these are. So clearly we can see that the size of this piece is smaller than either one of these pieces over here. Clearly it is. And the reason it is because I need 8 of them to make the same thing that only takes 2 of those and 3 of these. So it's worthwhile for us to work with our students and have them really get a good understanding that if I want to make this circle and I need 8 pieces, then that means it's going to be smaller size pieces. And the number of pieces that it takes to make the full circle is my denominator. This is how many pieces that I need. This is the total number that I need. And the bigger it is, the smaller the pieces are. And so, of course, here we have fourths. It only takes 4 pieces here to make that same size circle. And there, of course, we have 6 or whatever. So, okay. So it's worth our time and effort to have our students understand that the top number is how many I have, and the bottom number is how many it takes to make the whole. And the more important thing is than that, because most people will say, oh, the bottom number is how many it takes to make a whole, which is true, but that doesn't really help me. What I really care about is how big is this piece? Is it a third? Is it a fourth? Is it an eighth? So the eighths are much smaller pieces than the thirds or the halves or the fourths. So that's really what I want them to understand. Is there's an inverse relationship to the denominator. If the denominator is a big number, the pieces are small because it takes a lot of them to make a whole. If the denominator is a small number, then the pieces are big because it doesn't take very many to make the whole. Okay, so that's one of the key things. And you'll see that I actually don't use circles very often. Circles are nice because you can easily tell if you're missing something. So clearly I don't have all the pieces that I need there. And with some of the other activities that we'll do, some of the other manipulatives that we do, it's hard to tell what a whole would be equal to. But the reason we like to use circles is because you can clearly see if something is missing. So if something's missing out of here, it doesn't look like a circle. You know what it's supposed to look like, and it's missing something. So that's why a lot of teachers use circles. The drag with using circles is students are terrible at drawing circles, and it really gets hard for them to see what they're supposed to be doing. What I mean by that is this. So I'll demonstrate real quick what makes circles difficult for students. So if you tell them, okay, draw a circle and then cut it into halves. Okay, so they'll do this. They don't really care. When I say they can't draw circles, it's not they can't draw a circle like that. That's not my issue. And now show me halves. Just cut that into halves. So they'd do something like this. Perfect. And then you say, okay, draw a circle and show me fourths. Okay. And, maybe you're on this one, you say, color in and show me a half. So maybe they do this. Right? And then you say, okay, now show me fourths. And they go, okay, no problem. I can do fourths pretty simply. All right, so there we go. Now show me 1/4. And you go, okay, pretty good. There you go. There's my 1/4. So not a big deal, right? Pretty simple. And you say, okay, draw a circle and show me fifths. And you say, okay, there's my circle. And they go, okay, fifths. All right, so let's see. I got 1, 2, 3, 4, and 5. Literally, that's what they'll do. They don't know how to draw fifths because it's not easy like this. So if they need to draw fifths, they'll just draw fourths and just cut one of them in half. And clearly what they're not paying attention to is these all need to be the same size. That's what we're talking about. That's the same size as that. That's the same size as that, and that's the same size as that, and that's the same size as that, and that's the same size as that. That is not the same size as that, but they don't care. They just want 5 pieces. So, and fifths are hard to draw. I mean, there's no doubt about it. So, you know, they got to kind of try and estimate like a star looking thing. I didn't even do that good a job, but that's kind of what they're doing, is they're drawing like a star in the middle. So it's really hard for them to do anything other than halves and fourths. They might be able to draw thirds. You know, they're kind of used to like the Mercedes symbol or the peace sign kind of. So maybe they can do that and draw those thirds pretty good. If they can, then they probably can do 6 not too difficultly. But that's really it. After that, it's super hard to show anything other than halves and fourths, maybe thirds, maybe 6, but fifths are a nightmare. 7ths, forget about it. You know, it just gets harder and harder. So I like the circles at the very beginning because they can tell if they have all the pieces or not. If they have, you know, this amount and they know that they don't have a full circle, you can't really tell that with some of the other manipulators that we use. In fact, the ones that I had you guys buy, you can't really tell because they're rectangles and the rectangle might be all the way full. It's hard to tell. So, so we have to, a little bit later in teaching them, we're going to help them understand how the rectangles work. Okay, so that's the first part, is they have to understand the top number is the number of pieces and the bottom number is the number of, the size of the pieces, and that size of the pieces is inversely related to the number of pieces. Okay, so next what I'm going to have us do is I'm going to have us take a look at these. So this is another manipulative. These are called color rods, and I didn't have you guys purchase these. These were in the kits. If you bought the kit, then you have them, and that's cool, and I like them. But there's another manipulative that I had you guys purchase that I like a little bit more. So here's the color rods, right? So what we see here is that they seem to be going biggest down to smallest. Ooh, barely on the board there. Biggest down to smallest. And what you might notice is that the smallest one down here, this red one, actually would fit nicely to make two of them make the orange. And then one more red makes that yellow one. And then one more red makes that neon. And then one more red makes the green, fuchsia, lavender, purple, light blue, blue, brown, and gray. So what's missing each time is one red one. And so what that means is that we can consider this to be equal to a whole. This is equal to one whole rod. And each one of these is something less than that rod. So, and it's less by exactly 1 here. So what we're going to do is we're going to say, okay, there's 1 here, there's 2 here, there's 3 here, there's 4. And when I say 1, 2, 3, I mean 2 reds. So 1 red, 2 red make up an orange. 3 reds make up a yellow. 4 reds make up a neon. 5 reds, 6 reds, 7 reds, 8 reds, 9 reds, 10 reds, 11 reds, which means this is 12 reds right here.